Yes. Climate change, oh, is the kind of weather that a region has over a long period of time. Must be defined as a region's average weather. Tropical areas have warm, wet climates. Yes. Arctic areas usually have cold, dry climates. The sun's rays help determine climate. Phew. Now here's the equator. Yes. And then parallel rays from the sun. Now, this sun, yeah, that decides the climates of different locations throughout the world. Yes. We are spending billions upon billions of dollars because of the concern of global warming. Yeah. I told you that it was a complete waste of money. Pooch. But you're playing king because in your political life, it's all about the positioning of the chessboard. Yes. My thought was that when the sun shines upon a lake, water evaporates. Oh, that is, the water is taken into the air as vapor. See evaporation. It takes 540 calories of the sun's heat to evaporate 1 gram of water. If the evaporated water should later condense, change to liquid, rainfall occurs. See condensation. The rainfall returns 540 calories of heat from each gram of falling water. In such fashion, water constantly evaporates at one region, travels as clouds or in moist winds to another, and condenses and becomes rain. Now, I just explained to you about this steam. Yeah. Mhm. Steam, yes, is what is hot water in a vapor form. Yes, it is. And depending upon the actual temperature of it, how far up it goes into the atmosphere, eventually it will condense into what is known as rainfall. Now let's look at 2 trillion gallons of fresh water a year. That's a lot of calories, okay? A lot of calories that the sun's heat doesn't have to evaporate because I'm using heat manufactured from some other source. Yes, to change salt water to fresh water. Yes, so that it becomes a part of the atmosphere. And eventually it condenses into snow, depending on the altitude, or rain. Now, I know you said global warming is a huge problem. I mean, the whole world's concerned about it. We have conferences about it. Yes, we have laws and policies and all these concerns about global warming. And I said that you will not cool the earth without freezing the upper atmosphere. Now, a lot of you said, well, what we'll do is some weather engineering. Yes, because I've looked at your studies before. Somebody thought we should put like 1 million mirrors up above the planet Earth. Yes, point them to the sun and reflect the sun's sunlight back to the sun so that the sun would get the sunlight through outer space. Right. Then somebody else said, well, we can weather engineer if we can. And we could use a type of polarized aluminum as a shield, yes, from the actual calories necessary of the sun to turn water into vapor. Now, let's say you considered my idea. I have the availability of turning salt water, yes, into, well, steam. And steam at 100 degrees Celsius is actually boiling water. That's right. Anywhere between 220 degrees Fahrenheit to about 15,000 degrees Fahrenheit. Now, how much temperature of this whole process, yes, is necessary to get the steam from on top of the ocean to that part of the atmosphere where it freezes? Good question. Now, let's say, yes, I wanted to freeze the atmosphere, the upper part, might be 10 miles up. I don't know the exact location. But what if I did turn a whole bunch of what was salt water into freshwater steam because I got the salt and the electricity? I might not even get the electricity. I might just get the salt. I might not even do that. I might make the ocean a lot saltier. But anyways, I decided to freeze right around the whole globe, the whole Earth on the equator. Yes, a whole bunch of high temperature steam at 10 to 15,000 degrees. Now, where's the hottest part of the climate? It's around the equator. Yes, because we just seen that, didn't we? Yes. This is the parallel rays from the sun. Yes. Now, let's say I took a steamship, well, actually, one of these tankers. Yes. I put a hole in it. I manufactured some electricity using a wobbler motor. Yes. I put it into a metal, heated it up to 10,000 degrees to almost boiling point. Yes. And I set it in the ocean approximately, a foot down into the actual water. And then I scooted a whole, well, probably like 20 to 30 of these large oil tanker ships around the equator over and over and over. So as this 10,000 degree steam ends up in the upper atmosphere, freezes around the equator of planet Earth. Yeah. And all of a sudden you have this thick, might be, could be a foot, 2 feet worth of actual ice, might be a mile wide, 2 feet thick. Yes, of ice around the equator of the Earth. Now, that's going to cause a decrease in the amount of warmth that the planet receives. Yes. Now, it sounds really dumb, okay? But you will not cool the actual planet without making the atmosphere colder. Because the more ice.